In today's lesson, we're going to start looking at diagrams that incorporate triangles, but are not just two triangles side by side. So here we have a quadrilateral WXYZ, and it's split down the middle from X to Z. We're given some information about four of the angles, and we're asked to figure out, are the two triangles WXZ and YZX congruent? And at first you might be saying, well, we only have two angles and we need three pieces of information, so we can't, maybe there's not enough information. But if you notice, XZ is a side that is shared. Now XZ, by definition, has to be congruent to itself. So if I added in a marking here, suddenly we can see that angle side is a legitimate option for proving that the two triangles are congruent. So this is the first thing that we're going to look for in our complex diagrams. Do the two triangles share a side? Now, I used black here, but I'd recommend that you either use a different color for making markings or a pencil versus a pen so that you can tell what was part of the original diagram and what was a marking that you added onto it. Our next diagram shows two right triangles. We have triangle GHL and triangle KHJ. Now, I can find a little bit more information here. We're given one side of triangle GHL and an angle, and one side of triangle JHK and an angle. I know that this angle is also going to be congruent to this angle. And that's because they're a vertical angle pair. Now we have to go back to our question. Are the two triangles congruent? Well, I have an angle, and a side for triangle GHL, but I have an angle, and a different side for triangle JHK. Without any further information, we don't have enough to say that these two are congruent. We need the two sides that are labeled to be the same side. If we have triangles that overlap, so in this case, try to picture in your mind triangle EDG or EGD and triangle EFH. You see how they overlap in the middle? Now we're only given information about DF, GH, and then the two sides from D to E and H to E. But if you notice, this is an isosceles triangle. And something we learned about isosceles triangles is that the side opposite the two congruent sides, or the angle opposite the two congruent sides, are also congruent. So I could draw that in as well. Now, in this one, you had to take another leap because you have to remember that FG is also congruent to FG. So even though we're talking about the slightly larger triangles, we can still say that they're congruent because GF is congruent to GH and FG is congruent to itself. So even though we have to add those together to get side DG and side FH, they're still congruent to each other. So we can still use side, angle, side to prove that these two triangles are congruent. But it would be a lot harder if you didn't notice that it's an isosceles triangle. So we have a summary after this one where you can write down all of the different things that we made notes of. Now this one's showing overlapping triangles again. And honestly, it kind of blew my mind. I was starting to think, like, should I use isosceles triangles because the two angles are congruent? Or how should I approach this one? And so I redrew the two overlapping triangles to get a little bit of perspective. Now, each of the two overlapping triangles has one angle with a single marking, And the larger angle is made up of the single marking and the double marking. And I also saw that they share a side, VZ. VZ has to be congruent to itself. So I could use angle, side, angle to prove that those two triangles are congruent. Last, we have a list. Here are all of the things that we looked for: shared line segments, vertical angles, isosceles triangles, and we'll add on parallel lines. As we see some more parallelograms and quadrilaterals, parallel lines, we can use all of those properties as well. Some useful strategies and some things to think about before coming to class. You might want to use two different colors so you can tell what was given and what information you inferred. Because maybe you make an incorrect assumption, you can always erase your pencil markings. Redraw overlapping figures to help give yourself perspective. And if you're preparing a proof, it might be helpful to list your known information and what you inferred from that information. So because this is an isosceles triangle, this is the information I inferred from it being an isosceles triangle.